He has like a
Yeah.
2019 layer.
No.
Wait, is it a Red River or Ridge
Yeah.
River? Is James River Red?
It's
Red
like,
River or
it's
Ridge
like
River?
a green one.
All right, listen up so we get rolling here.
It's like a long, it's a long. Yeah.
It's a Land Rover.
That's what it is.
So today we are going to start. Today we're going to start algebra proofs. So it'll line up very closely to what you did last year, and then Thursday we will start geometry proofs. Now remember to get your date on that. Oops, not Monday. Now, before we start our proofs, we are going to write out the different properties you're going to need to know. These are on your cheat sheet that you get to use for the test, but if you don't know how the properties work, the cheat sheet really doesn't help you a whole lot. So we need to know these different properties. These all go back to algebra last year. So hopefully there's nothing new here today for you. We're going to start with the addition property. And if you remember back to yesterday, we said the addition property allows you to add the same thing to both sides of your equation. So here's how it looks. If A equals B, then we can add the same thing to both sides. We can add C to both sides of the equation. You add C to both sides of A equals B, you get A plus C equals B plus C. Addition property lets you add the same thing to both sides of the equation. Addition properties first, what do you think second? Subtraction property. Now, if you're going to abbreviate subtraction, you're going to have to go to 4 letters. And I'll show you why here in a second. We also have a substitution property coming up in a little bit. So if you just abbreviated SUB, that's going to cause problems. So if you do abbreviations, make sure you abbreviate it enough so I know which one you're talking about. Now we'll let you kind of piece this together. It's going to start off the same way. It's going to say if A equals B. But the subtraction property is going to let us subtract the same thing from both sides of the equation. So if addition property said if A equals B, then A plus C equals B plus C. Subtraction property after the A equals B, what do you think would happen? We're going to minus C from both sides. Subtraction property allows you to subtract the same thing from both sides of your equation. Next comes the multiplication property. And just like the first two, multiplication property is going to start off if A equals B. Anybody think they can finish this one off? Multiplication property is going to let you multiply the both sides of the equation by the same number. Any guesses? Jackson, what'd you say?
Huh?
What'd you say?
A times C equals B times C.
There you go. A times C equals B times C. Multiplication property is going to allow you to multiply both sides of the equation by the same number. And then division property will let you divide both sides of the equation by the same number. So this time around, we're gonna take the A equals B, we're gonna divide both sides by the same number, in this case, C. A over C equals B. Those four are probably gonna be the most common ones you use here in this first section when you're doing the algebra groups. So before we move on from there, any questions with the first four? How many people remember seeing this last year in algebra? Some of you do, okay. Now we're going to get a few others that will probably sound familiar to you, but you may have forgotten what they are. Reflexive property is the first one. Reflexive property is a real simple one. It's just going to say that something equals itself. A equals A, angle 1 equals angle 1, X equals X. Something is equal to itself. That's the reflexive property. Now, you're probably going to look at that and think, well, that one's not real important, but we actually use that quite a bit when we start getting into the geometry groups. So you will see the reflexive property a lot also. All right, I told you that we're going to get, no, actually, no, we're not there yet. Next one's symmetric property. All right, with the symmetric property, let's start off saying if A equals B. And this time we're going to show symmetry. And the symmetry is kind of like a mirror image. If you look in the mirror, you're going to get your image back, except it's going to be backwards. So if A equals B, then B would equal A is the symmetric property. Or you can think of it like when you were in third grade, you're making little paper valentines. What you do is you take a piece of paper, you fold it in half, you draw half a heart on there, cut it out. When you unfolded it, you'd have the same exact shape on both sides. Same thing here. If you think of this pen as being the fold in the paper, the A would fold over, fit right on top of the A, the B would fit right on top of the B, equal sign on top of the equal sign. That is symmetry. Symmetric property just lets you flip around the two things on both sides of your if-then statement. Next one is the transitive property. And my guess is you guys can finish this one off if I start it for you. It says if A equals B and B equals C, then something's going to happen. Anybody want to take a guess on this one? If A equals B and B equals C. Anybody figure out what we could say?
A equals C.
There you go. A equals C. Since they're both equal to B, they are equal to each other. That is your transitive property. And we got two others. Substitution property is the next one. And we'll write this one out and then we'll kind of talk about it. It says if A equals B, then A can replace B. If you have an equation where A equals B, or you have an equation and A and B are the same thing, you can take out A and put B in for it. Substitution property, you kind of think of this one as like a high school basketball coach. If the basketball coach takes out his center, who's he probably going to substitute in? Probably going to substitute in another center. If he takes out his point guard, he's probably going to substitute in another point guard. Okay. So if A and B are the same thing, you can take one out, put the other in for it. That's your substitution property. Now, this is where you got to be careful if you're abbreviating. Subtraction and substitution both start with SUB. So if you decide you're going to substitute, or if you're going to abbreviate, you're going to have to go at least 4 letters when you do your abbreviation. you just put SUV period, I won't know which one of the two you're talking about. So if you abbreviate, make sure you go out at least 4 spots there. All right, last one is the distributive property. We've already talked about distributive property this year. And this one, we're not going to put it in then form. We're just going to put it as equation. You have A times the quantity B plus C. Distributive property is where you're going to distribute that A to both things inside parentheses. If I distribute that A on this one, can anybody finish it off for us?
AB plus AC.
There you go. A times B would be AB. Your plus stays in the middle. A times C is AC. Distributive property, you're just distributing that number in front of the parentheses. Two of the 2 parts inside your parentheses. All right, now these properties, although you did them all last year, these are going to be very important. They will be on your little cheat sheet that you can use for the test. But if you don't know what these theorems mean, or don't know what these properties mean, that cheat sheet doesn't really help you a whole lot. So you are going to want to make sure you know what these are and how they work. And if you do, then using that cheat sheet should be fine for you. Okay, let's move on to the proofs. The type of proofs we're going to do this year are called 2-column proofs. So here's how a 2-column proof is going to work. They're going to give you a given statement. Let's call this one letter A. We're going to have 2 of these, so we'll call this first one letter A. And today we're just doing algebra proofs. When they do algebra proofs, the given statement is usually going to be an equation. So our given here is going to be -5 times the quantity x plus 4 equals 70. The given is where your proof is going to start. We're going to start with that equation right there. Then they're also going to give you a proof statement. Proof statement is where your proof is going to finish. We're going to prove on this equation here that x equals -18. And then I told you we're going to have 2-column proofs here. So what we're going to do is make a kind of a T-chart. There's going to be your 2 columns. The left-hand column is going to be where your statements go. The right-hand column is going to be your reasons. And as we go through this proof, every step we put in there, we're going to be able to put in a reason to explain why we're doing what we're doing. All right, here's how it starts. Usually they'll number these as they do them. So first step. First step is almost always going to be the given. I can't think of any proofs where we don't have the given first. So your given is -5 times the quantity x plus 4 equals 70. And then your reason for that was given to us. Your reason is going to be given. Like I said, almost every single proof you will ever do, that's how it's going to start. You have a given statement, your reason is going to be a given. Now, for our second step, here's where we kind of run into a problem. The book will kind of do these proofs one way. Alex does them just a touch differently. So I'm going to show you all of the steps in case you run into this on Alex, because sometimes I'll put in some extra steps. So what we're going to do here is this next step. When we have this first equation here, we have a number out in front of parentheses. When you do that, you're going to distribute the -5. So what we're going to do is show that we're distributing the -5. We're going to take -5 times x, -5x. We're going to take that -5, -5 times 4, still gonna have to equal 70 over here. Now, I believe this is the way the book will typically do it. Maybe it's the way Alex does, I can't remember. They're gonna show that actual -5 being distributed to both parts. And then they will call that the distributed property. And if you want to abbreviate, you can. Just remember, you got to be careful when you abbreviate substitution and subtraction. But it's fine with me if you abbreviate. Now, if this proof was done on Alex, Alex would skip this first step and go right to the next step. The -5x will stay a -5x. When you distribute the -5 times 4, you get -20. That -5 times 4 is -20. And we got 70 on the right. And when they put this step in there, Alex or the book, whichever one does it, we'll call it simplify. All we did is we just took this -5 times 4 in the first problem and multiply them together to get -20. All right, now we're just down to basically solving the equation. So each step just follows down, you're just solving the equation, putting in your reasons as you go. So if you had this equation right here, -5x minus 20 equals 70. Going back to algebra last year, what would be the next step to this? You're going to add 20 to both sides. So once again, it's either Alex or the book. One of the two will show the adding 20 to both sides. The other one will not show adding 20 to both sides. So we kind of have to show you how this works if the step isn't there. So now what you want to do is you look from the previous step to the current step. This previous step to here, we added 20 on this side and added 20 on this side. Which property allows us to add 20 to both sides of our equation? Which property did we just go through? Allows you to add 20 to both sides. Addition property. Now again, let's go ahead and put this together. The -20 plus 20 becomes 0. That leaves you -5x on the left. The 70 plus 20 on the right is 90. And we're going to call the reason for that simplifying. Added those things together. All right, only got a couple steps left. We got -5x equals 90. If you were going to solve that equation last year, you would divide both sides by -5. So in this one, we're going to show that actual division by -5 on both sides. And hopefully you're starting to get the hang of it. If we divide both sides by -5, which property lets us do that? Division property. Last step here. Go ahead and divide them by -5. -5 divided by -5 is 1, leaves you 1x on the left. 90 divided by -5 is -18. Anybody tell me what the reason would be for that? Any ideas? Go back to step 3. Multiply those together, call it simplify. Step 5, when you added the 20s, or when you added the 20s together, we call that simplify. Here we're dividing both sides by -5. When you actually do the division, that's called simplify. And then we're finished because we got to the point where x equals -18. That's what we wanted to prove. This right here is a 2-column proof. Started with your given, you worked through all your steps until you got to the proof statement. For each step, you had a reason to explain why you did what you did in that step. That's a 2-column proof. Any questions with the first one? All right, anybody think they're getting the hang of it already? You are, okay. Let's try a few more. Call this one letter B. Once again, you're going to be given a given. Our given is 5x plus 1 over 2 minus 8 equals 0. We're going to prove that x equals 3. We're going to prove this by just going through and solving the equation. So let's set up our 2-column proof. Statements go on the left. I'm going to abbreviate that S. Reasons go on the right. I'm going to abbreviate that R. Let's go to step 1. First step on a proof, what's it always going to be? Start with that given. Given is 5x plus 1 over 2 minus 8 equals 0. What's my reason for that going to be? That's given to us. So no matter how difficult the proof is, you should always be able to get step number 1. Put the given in there. That's your first step. All right, let's go to step 2. Step 2, if you had this equation last year, what would you do to solve this equation? What would be the first step you would do to solve that equation? You're going to do what? You're going to add 8 to both sides. You got a minus 8 here, so you add 8 to both sides. Now, up here we showed you where they actually show that addition on both sides of the equation. And then the next step was simplify. Sometimes, let's say we're doing this on Alex. Alex may not show that step. So if they do, if they don't show that step, if you add 8 to this side, you're left with 5x plus 1 over 2 on the left. And then if you add 8 to the right-hand side, you get 8. Now go back to what we talked about a little bit ago. We added 8 to both sides of the equation. Which property lets you add 8 to both sides? That's the addition property. So now you've seen it both ways. So if you're on Alex and they do show the actual, let's see, like this. If they do show you actually adding 20 to both sides, you do addition property there. Then when you simplified it, you call it simplify on the next step. If they do it all in one step, they add 8 to both sides, which makes this disappear and makes this become 8. Then you just do it all in one step, call it the addition property. So you'll probably see it both ways as you go. All right, now we got 5x plus 1 over 2 equals 8. You're going to solve that equation. What would you do next? Five x plus 1 over 2 equals 8. Peyton, what would you do next? You have to solve that equation. Solve that equation. What would you do next? Anybody help now? Vera, what do you think? Multiply both sides by 2. We're going to get rid of that fraction on the bottom. So if we multiply both sides by 2, once again, sometimes they will show the actual multiplication by 2 on both sides. This time they're not. They're going to just go ahead and do the step. So if you multiply this left-hand side by 2, you'd be left with 5x plus 1 on the left. And if you multiply the right-hand side by 2, you would get 16. So we multiplied both sides by 2 to solve that one, or to do that next step. Lily, if you multiply both sides by 2, what property is that? Multiplication property. Multiplication property lets you multiply both sides by the same number. All right, now we're almost there. A couple more steps and we got 5x plus 1 equals 16. If we were going to solve this equation, Maria, what would you do next to solve that equation?
-1.
Get a -1 for both sides. So sometimes they'll show them -1 on both sides, sometimes they won't. This time we're not gonna. Let's subtract 1 from this side, you're left with 5x on the left. 16 minus 1 is 15. Landon, what property is going to let us subtract 1 from both sides? Subtraction property. Can I abbreviate it SUB?
No.
No, why not? What else could be SUB? Substitution. So if you're going to abbreviate, better go at least 4 steps, 4 spots. I'm going to go 5. That's subtraction property. Best bet's just write it out with subtraction property. Then you don't have to worry about that abbreviation. All right, last step. Get to where we need it. You have 5x equals 15. We want to solve that. Ava, what would you do to solve 5x equals 15? Divide both sides by 5. That's going to be x on the left, 3 on the right. And Adam, which property lets you divide both sides by 5? Division property lets you divide both sides by 5. Proved x equals 3. That's what they wanted to prove. You're finished. Not yet. Any questions of that one? I think they're starting to get the hang of it now. Okay. What happens is, as you see, every time you see another one of these, it gets to be a little bit easier. All right, next one. We'll call this letter C. This time we're going to be given that -1/3 n equal to 12. And we're going to prove that n equals -36. Once again, I'll put statements on the left, reasons on the right. And this one's going to be a real short proof. Now, since you're brand new to proofs, when we get to our test next, let's see, it'll be next Tuesday for you guys. When we get to the test, instead of making you do all of the steps, we're going to have it be a fill in the blank. So we're going to start to do some of them this way. So this one's going to take us 3 steps to get there. What I'm going to do is fill in part of it, and then we'll fill in the blanks. Just copy down what I'm doing here. Then. Now, at this point, my guess is some of you could probably do this all by yourself. Fill in these blanks, no problem. Some of you may not quite be there yet. But this is what it's going to look like next week when you get your test. It's going to be a fill in the blank. You're not going to have to put in every single step. You're just going to have to fill in the missing parts. So let's see if we can do this one together. Anybody need more time to copy it down? All right, let's start with first one. Step number 1 says -1/3 n equals 12. Step 1. John, can you figure out where that's coming from? No, Nick, sorry. -1/3 n equals 12.
Oh, yeah.
That's your given. That's your first step. Given right there. Now, the second step. Can anybody figure out what they did to the first equation to get this second one? Walker, what do you think? They multiplied both sides by -3. The -1/3 n, they multiplied by -3. The 12, they multiplied by -3. What property lets us multiply both sides by -3? Multiplication property. And now we're almost there. Let's see. We did the multiplication property. The next step that they're telling us to simplify, when it tells us to simplify, you just go ahead and do the multiply. -3 times -1/3 becomes 1, leaves you n on the left. 12 times -3 is -36. Once again, that's what we wanted to prove, n equals -36. We did it through that simplify. 3 steps, you got your proof. All right, how many think they're getting the hang of it now? Picking up a few more each time. All right, one last one to get. Once again, I'm going to write this out as if it was the test next week. So it's going to be fill in the blanks. We're going to see how many. Like always, you'll have your statements on the left. Your reasons will always be on the right. All right, let's do it a little differently this time. First step, we're going to fill in the statement. They're going to give us the reason is the given. This one's going to take us 5 steps. And if this was your test next week, each one of these blanks you're filling in would be worth a point. Second, get it written down here before we start it. Who needs more time to write it down? Okay. You know what? Let's do something different this time. Let's see how many of these you can fill in all by yourself. And then we'll come back and do it together when you're finished. So go ahead at this point. See how many of these you can fill in all by yourself. Just to get a glimpse of where we're at this point. You already have it done.
Yeah. No, okay.
Subtraction goes with this step up here. Subtract one on both sides. So this thing tells you what the previous step to do. Okay, these are looking pretty good. Anybody want more time to finish it off? All right, let's see what your thoughts are on this one. Taribo, what do you put for the first step?
Oh, the first one?
Yep, the first one.
6x.
There you go. 6x plus 12 equals 30. That comes right from the given. All right, that's first step. That's given. From the first step to the second step, we subtracted 12 from both sides. So, Landon, what do you think that one's going to be? Subtraction part. Can I abbreviate it SUB period?
No.
No. Then I won't know if it's subtraction or substitution. So if you abbreviate, make sure you go with these 4 letters. Okay, now the next step tells us to simplify. So we're going to actually subtract the 12 from both sides. And Layla, when you subtract the 12 from both sides, what do you get for your third step?
6x equals 18.
6x equals 18. Very good. Okay, now we're going to go from step 3 to step 4. Step 3, we've got 6x equals 18. Step 4, they're dividing both sides by 6. And let's see, what haven't we called on yet? Allie, what's going to allow us to divide both sides by 6? We're dividing both sides by 6. Division, yeah. And then our last step, we're going to actually do the division. 6 divided by 6 is 1, leaving 1x. 18 divided by 6 is 3. Anybody remember what we call this step? Walker? Simplify. All you did was simplify those. There is your proof. Is anybody able to get all 5 all by themselves? That looks pretty good. All right. How many think they have a better understanding of proofs now than when you started today? That looks good. Okay. Any questions on these? Does anybody want to see more of them?
No.
You guys just want to do your homework?
Yes.
Okay. Now, I'm going to hand you the homework. This assignment, let me turn off the video here first.